Talk to me about systems of equations.
If it crosses twice,
So we did systems of linear equations earlier this year, right? And we had one line that went right here, and then we had one line that went, I don't know, right here. And where was the solution?
In between.
wherever it was, where they intersect.
Double shaded.
Where they intersected, right? Where they intersected. This is the solution. There's one solution, and it was where they intersected. You remember that? Was that the only possibility? What was another possibility?
Parallel and one out.
So one was right here, and one was right here, and that was what? No solution. Do I need to write out the whole word solution, or do you know what I'm talking about, or if I write SOL?
You know what you're talking about.
Okay. So were those the only two possibilities?
No, they can be on top of each other.
Okay, so one line was right here, and the other line was right here.
And it'd be all real.
Infinitely many solutions. Right? What have we been talking about for the last week? Last, I guess, 4 or 5 weeks.
Quadratics.
Quadratics. So what happens if I throw a parabola into the mix?
There could be two.
How could there be two solutions?
Because one parabola is positive and one parabola is negative, and they intersect twice.
Truly, if one
So can I put the brakes on real quick? What if I had a parabola and a line?
then you'll probably
Keep
you'll have-
keep that in your thought. We're just not there yet. Great thinking, but we're not there yet.
They could still intersect twice.
How would it intersect twice?
The line goes through one side of the parabola and the other side.
So like that?
Yes.
Okay. So 1, 2. So 2 solutions. I don't want to spoil anything, but I'm going to go ahead and draw the next 4 graphs.
You could have one solution.
How could I have one solution with a parabola and a line?
So you have your
The line.
the line that goes through the bottom, the vertex.
Oh, okay. So if I just have my parabola right here, and you want the line to go like that, so that there's one solution and just happens to be the vertex?
Or if the parabola opens vertically, it goes through the y-axis. Or the line's on the y-axis.
What if you?
I think I see what you're saying, but it's pretty much the same as this, right?
Yes.
And, no, I'm not going to say that yet. Okay, what did you say?
Could you have it to where, like it would only, like if your line was slanted, it could only touch this point?
Okay, so
Of
you
the
want
right
something
side.
like this, and then you want something like this, so that they're actually touching right there.
Yeah. Or like it goes this way, like it touches the top of that parabola.
One solution.
Up there.
Well, the parabola goes on infinite.
Everybody understands that, right? I haven't been drawing the arrows, but you know this keeps on going, like that, right? I can't draw the whole parabola because I don't have enough paper in the entire universe
You
to
have
do
no
that.
solution.
Oh, we could have no solution? Wait, I need to talk to you real quick about this one, real quick, one more time. What's this called? What's this called? There's a very specific name for these two answers right here.
Solution of the equation.
Tangent.
Mm-hmm. Isn't that what the definition of a tangent is? It only touches in one place? Yeah?
Take me back to his patents.
So, you want, what were you saying, Camp? You want no solutions?
Yes.
What does that look like?
So if you have a parabola that is going down like this,
Uh-huh.
and then you can just draw a line like above it.
Oh, like this?
Yes,
So that would be no solution?
correct.
Does it have to be a parabola opening down?
No, it could be up.
It just has to have the line above or below the maximum.
So if my parabola opened up like this, then my line could be like here. Is that what you're saying? Okay. So with a parabola and a line, are our only options none, 1, or 2?
Oh, no. No, because it would be
The line is
infinitely.
like this.
We have a parabola and a line.
It could be
By definition, lines are straight.
Infinitely.
like that.
But what if we did? Aren't
If there's infinite, then it has to be a.
Can I have infinitely many if I have a parabola and a line?
No.
No.
Because the line can't get all the points.
Because a parabola is curved.
So if I have two lines, I can have one, none, or infinitely many, right?
Yes.
If I have a line and a parabola, I can have 2, 1, or none. And that's it, right? Okay. Now think outside the box for me for a second. Can you think of a way, if I have a system of equations, that I could have 3 solutions? Or 4. We can say 3 or 4.
Two parabolas.
2 parabolas, okay. So if I have 2 parabolas, how do you want me to draw the 2
One
parabolas?
would be sideways.
Yeah.
So if I have a parabola this way and a parabola this way,
That's only two.
that's only 2.
It has to be
Right?
a sideways parabola.
I've got one here and one here. That's great. So you're saying I want to have one parabola right here and one parabola how?
Sideways.
So a horizontal parabola?
Yes.
Yes.
Okay. What am I going for here? 3 or 4? 4, okay.
Oh, that's cool.
1, 2, 3, 4. 4 solutions. So tell me how I could have 3 again?
If the vertex is only on one point of the parabola, like that, and then it touches one
Like that?
point. Yeah.
1, 2, 3. So this gives me 3. Can I have 5?
Yep. You gotta have 3 parabolas.
Oh no, we're just only having 2.
We could have polynomials.
No, go like this.
Yeah, we could have polynomials.
But we
I
want
don't think you
parabolas.
can have 5.
I'm asking for parabolas.
I don't think you can have.
Yeah. Many.
Oh, you can have infinitely many. Okay, how would we have that?
Overlap like the
Two
line
parabolas on top of each other.
Here's a parabola. And here's a parabola. Oop. Sorry. Infinitely many. But I can't have 5?
No.
Your voice is making me doubt myself.
I don't think we could have
I don't
that.
think you can.
Because, like, there's no way that you could have it touching more than 2 pieces.
Yeah, I don't.
Wait.
Wait, I think I'm right.
What you want?
So if we draw our graph, and then we draw the upside down parabola.
So
facing
vertical
down.
but facing down?
Yes, ma'am.
Like that?
And then couldn't we line our parabola up with the vertex of it, but also putting it through, like
Oh!
kind of like.
That's a shot.
Like, and so then it would go right here, right here, right here, and right here. Would that be 5?
It's 5.
4, but I see what you're doing.
1, 2, 3, 4, 5. Right? If it's like, or maybe that's still 4. I don't know.
So how do you want me to draw it?
Like,
That would still be 4. That would still be 4.
Draw it with the extra line.
Yeah, use that.
Yeah, use the extra line. Like, I don't know, it might still be 4. I might be tripping, but
It would have to be pretty steep, I feel like.
yeah.
Go.
Well, with the way you're curving it, with the parabola,
No,
letting
I
that
have to
touch
go
you.
back through, yeah.
That's
It's 4.
That's just 3 right there.
yeah, that's 3.
If you draw it, that looks almost exactly like this. It's just higher.
Oh, yeah. I was trying to think.
What? Can you have one?
Yeah. The
Yeah. If you
vertex.
do
You have the
upside down,
vertexes
is the
touching
vertex touching?
each other.
Yeah.
We're
I
trying to
don't know
find
what I
5
was
right now.
That's okay. We'll go ahead and draw 1 because we're talking about it.
Yeah.
1 is right there with the vertexes touching. Is that the only way with 2 parabolas that we can only have 1 solution? No, it's not.
You have to be horizontal.
Yeah.
What if we did this and then this? Wouldn't that just be 1? So with 2 parabolas, we can have 1, 2, 3, 4, or many. Is that it?
Yes.
We can have 5.
You can have what?
We can have 3, but I don't know how.
Can you?
You could have 0.
You could have 0.
Oh.
How could you have 0?
No, if
If
they lived
one's-
in two different states.
One's positive, one's negative, but there's a gap in between the verses.
Oh, okay, so if one's here and one is here,
Yeah.
that would be no solution, right?
Your voice is making me doubt whether there's 5 or not.
But what if I also had like this one and then I had this one?
Oh, yeah.
Wouldn't that be also no solution?
Yeah.
We'll come back to the 5 in just a minute. I want you to think outside the box. Think outside the box.
I like it in the box.
And tell me any other kinds of things that you can think of and how many solutions that they have.
I don't have enough room to do that.
Are we only doing parabolas and straight lines?
Nope, not anymore.
Oh, a parabola and a blue line like that.
Okay, so
A polynomial?
Yes.
You could say that.
And you can have a lot of them because it just be like that.
okay, so first of all, if it's like this, that's not a polynomial because that's not a function.
Not a polynomial. I just said a line like this.
Okay,
Yes.
Not a lot.
Only one. That's like
Macy,
one.
Macy, it has to run left to right.
That is actually not the fun.
Because if we were to draw a line that intersects at multiple points,
That's so hard. Like
Yeah,
this.
the one that.
and you want it to, it has to be this way,
So
it can't be this way?
No, draw vertical for.
Okay, so like,
I don't care. I just want to see what it is.
I'm not.
let me show you exactly what I'm talking about so you know I'm not just making it up. You guys should have already seen this, but just in case, I'm going to add a graph.
Show you how to. I'm not.
The
graph can go like this. It can't.
Yeah, because then it
I've
makes
seen
the
it
weight.
Wait,
Whoa.
that doesn't touch that.
Hold on a second.
Say, do not go too far.
It touches it, but it's not.
Alright, I'm sure that right now.
Because
What the heck?
Life is Roblox.
So you can't do one that's like.
Like this.
it's not.
Like, and then just like. Because it's not a function.
Other way.
Macy, because if you were to do the vertical
The
line
vertical line
test, it
test.
hits multiple points. They're the same.
If you raise your butt.
Macy, if you do it sideways,
That's still not a
I don't
function.
understand what's happening right now. Okay, I'll mess with that and show it to you again. All right, what are you drawing?
Like this. Okay, we can do it like this.
that's the function.
So how many solutions is that?
2.
Two.
So you're saying we should have a parabola?
Wait, but then let's make it like tighter.
This is what I was trying to show you. I was trying to show you a sine wave. Have you ever seen a sine wave before?
No.
Like this?
Sorry.
Sine waves look like this, something like this. Sine waves, cosine waves look like this. So we've got 1, 2 solutions here.
What's a tangent wave look like?
Oh,
Well, I
there's
can't
one.
get my calculator to do anything right now, so
So you can't do it the other way?
it's not a function.
But let's make it one. Can it be now?
Did you say let's make it one?
Yeah, he did.
Oh wait, you could do it like that, but you could have 3.
Or you can have 4 points with
You have 3, 4, 5, 6, 7.
Why are you locking things?
Okay, I don't know what was happening with the other calculator, so I just grabbed this other calculator. This is a sine wave.
It looks exactly like
pretty.
Mrs. drawing.
Okay, so that's what I was talking about. See how it goes to the origin, and if I zoomed out, it would just keep going like this forever, right?
You could do it, Miss Kingston, you could do it like that, but it could have 3 solutions because it could be like
It could
this.
have
And then
3,
you
4,
could
5,
touch
6,
it.
7.
Well, and remember, depending on
Yes.
On what your sign is.
that's just a parent function, right? But if I do something like this, it makes it steeper.
Radio waves.
Or if I,
We have that test.
you know, all the transformation rules, right? If I put
Yes.
that in there,
I'm supposed to.
I can make it be like that.
I like that one.
Okay? So if we put a parabola in there, that would be a lot more solutions, right? Okay. What about this one?
That's not a function.
It's not, is it?
No, because it
But
doesn't work.
but this is something that we have worked with before and we will work with in the future, so I want you to use to be the fact that we can use a circle.
Don't get me started on circles.
What about like the...
I have one more to show you, and it's infinitely many solutions, but it's not 2 of the same function on top of each other. God bless you.
Let's do the same circles.
It's not.
Oh, is it if you have a straight line and then one of the... Oh,
So it's like the sine wave that I just showed you, and then what if I just did a horizontal line through that?
Oh.
because it would keep going.
No, it's not touching every single point, but it's here and 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 all the way, right? So that would be infinitely many, right?
Yeah, I do, actually.
All right, so for all these beautiful drawings that we just did, well, what was the point?
To just show us all the ways that I could do.
I wanted you to remember, how do you find the solution?
By counting.
Intersection, right? The points of intersection are the solutions. Now, I wanted you to get this visual in your head that these are all possibilities.
Oh yeah, isn't it the degree and then subtract 1 and that's your terms?
That's a turns, that's something different, but I'm glad you remembered that. Okay? So, today we're going to talk about nonlinear systems. What does that mean?
It's not a straight line.
So, what does a system mean, though?
More than one.
More than one, right? So, for it to be a nonlinear system, can you have a line in a nonlinear system? Yes. They're not all lines. Okay? So, let's talk first about this. Here's our first example. If I tell you y equals the absolute value, not absolute value, I don't know why I said that. Quantity x minus 3 squared plus 5 and y equals 5, how would I go about solving the system? Now, good news, bad news. Bad news is that you cannot solve nonlinear systems with a matrix. You also, most of the time, cannot solve nonlinear systems with elimination.
Or substitute.
Substitution is pretty much our only choice.
Oh,
We can graph it, but with the graph, we don't have any of the work.
That's the question.
Okay? So here's the deal. Let's solve this one substitution. And I'll show you why the fact that you're freaking out right now is kind of funny. Well, if y equals this and y equals this,
Just plug in your...
doesn't this equal this? Can't I plug this in right here?
Oh.
So x minus 3 squared plus 5 equals 5. Right?
And then isolate your x minus 3 squared.
Why would I want to isolate my x minus 3 squared?
Because that's what the teacher
Because
said.
it has the variable.
It does, but why would I want to do that?
So you can square
square root.
So you can square root it, right? There's no other x term that's outside of this square, this parenthesis, is there? No. Okay. So I
just
want
like
to
we did
isolate this squared term in this particular problem. So to do that, I'm going to subtract this 5 from both sides. Now look what happens when I do that. X minus 3 squared equals 0.
Oh, man.
I'm still trying to solve for x, and I'm still going to do it the way he suggested, which was by square rooting both sides. And on the left-hand side, I get, and on the right-hand side, I get 0. Now, normally this is the part where I ask you, wait, who put the plus or minus, or who put the root sign in, so who has to remember the plus or minus? But it's 0. There's not plus or minus of 0, is there? So if I add 3 to solve for x, I get 3. And that's the end, right? I need to substitute it. I need to find, what am I looking for? What's the answer?
Why? Wait, what?
What is my solution?
The answer to the.
3.
What is my solution? The ordered pair, the point of intersection, right? So if I know that x equals 3, go back to the beginning. Look what happens in this particular
Right there.
problem.
So it's 3, 5.
It tells us what y equals. So I'm not all the way finished until I write my points of intersection, or point of intersection. That is correct. Okay? Now, 3 squared, 3 minus 3, 0 squared,
0.
plus 5.
5.
Does 5 equal 5?
Yes.
And then does 5 equal 5? So is this correct? Yes. And then for this, so this is a parabola, isn't it? And a line. So this is one of the things that looks like one of these, right? One of these. It looks more like this one, because one of my equations is y equals 5, right? So there's only one solution for this one. Any questions so far? Then let's do this one.
Y always equals 5?
It happens to be yes. Y does not always equal 5. Sometimes it looks like this. Let's do this one. Y equals negative 3. If you guys are going to cry about this, I do have Kleenex on my desk. Yeah.
You go ahead and pass the box.
Yeah.
I'm
I'm not sure if I have enough Kleenex for this particular class. Anyway.
Gosh darn it.
Probably not.
Dibs.
Dibs on the Kleenex
Yes.
for
Dibs on
crying.
13.
Awesome.
13 sheets.
Y equals negative 3x squared minus 30x minus 71. And y equals negative 3x minus 17.
You could plug it in.
So you want to plug this one into here?
No, you will. Oh, well, yeah.
Yeah? So negative 3x minus 17 equals negative 3x squared minus 30x minus 71.
So long equation.
Okay. Once again, Kleenex is on the desk.
Make it equal to 0.
Make it equal 0. Okay, so what are we going to do to make it equal to 0?
You get them to both sides and then combine like terms.
Get them to both sides and then combine like terms.
Add 3x and 17.
Add 3x to both sides and add 17 to both sides. That's what I heard. Is that correct? 0 equals negative 3x squared minus 27x minus
6.
I knew it was
I was about to say 67.
Now what do you want to do, guys? Because this seems like a whole lot like problems that we've been
GCF.
doing.
I want to take
GCF would be
Yeah, I
great,
agree.
right? GCF would be a great thing to do right here. What would be the greatest common factor here that we want to divide out?
negative 3.
Negative 3 would be a great thing to divide out. 0 equals
X squared plus 9x plus 16. Is it?
It's plus 6.
No.
Plus.
Oh, I'm still on the 9x.
Wait, it's 9 and
Is it like 18?
It's in fact not just like 18, but it is 18. But you're all sitting there staring at the board.
And we have this.
Yeah.
Wait, so I got it right?
Restrooms in my
Answer.
backpack.
Yeah, I got it right.
And then you could
Then you can
Factor.
factor it.
You could factor it. How do we want to factor this one?
AC.
AC.
Okay, so what do we get?
18 and then 9.
6 and 3.
6 and 3. So x plus 6 and x plus 3. If you are to the point where you can do what I'm about to do, you have my permission to do it. Because you know how I feel about showing your work,
Isn't it just
right?
AC
You know
negative
you know how I feel about showing your work, right? If you are to this point where you can say now x equals negative 6 and x equals negative 3, I'm okay with you doing that. Some of you will need to say x plus 6 equals 0, subtract 6 from both sides. X plus 3 equals 0, subtract 3 from both sides.
And then,
But I'm telling you right now, you have permission to skip that step if you can.
so there's two solutions.
Oh, wait. This is not the answer? I don't put that in ordered pair and say negative 6 comma negative 3?
No, 'cause
No,
they're
you
both
don't.
X. You
They're
plug 'em-
both x,
you
right?
plug 'em
That's a
in
good
the
observation.
equation. You plug 'em
So
in the-
can I show you what I do at this point when I'm doing these problems? Once I know that I have two x values, I go ahead and start writing my answer. Because I don't like to leave blanks. I know that I have 2 points and these are my x values. Now I need to fill in the y values. How am I going to figure out what the y values are?
You just plug in one and then plug in
One at a time, right? Y equals negative 3 times negative 6 minus 17. What is negative 3 times negative 6?
Negative or positive 18.
So 18 minus 17.
1.
So when x is negative 6, y is 1. Y equals negative 3 times negative 3 minus 17. What is negative 3 times negative 3? 9. 9 minus 17.
Negative 8.
So when x is negative 3, y is negative 8.
What would you have?
No, I don't have 4. I just have 2. Because I had 2 x values, so now I have 2 y values. Does that make sense? Could you be absolutely certain that these are both correct? How? Plug them back in. Put the x here and make sure that y is 1. Put the other x here and make sure that y is 1. Put the x here and make sure the other y. You don't really have to do that because that's where I got the y's, right? But you absolutely could graph these two and make sure that they cross at these points. That's a very good suggestion. What you got?
Does it matter? It doesn't matter what equation we plug it into, right?
It does not. That's a great question. We could have taken the negative 6 and the negative 3 and plugged it into the top equation, but I think they chose the second equation because it looked easier. Yeah. Okay so far?
Yes, ma'am.
Let's do this one.
Oh, Lord. Oh, this one doesn't seem that bad.
Y equals negative 2x squared minus 9, and y equals negative 4x minus 1. So first of all, before we start, tell me what two shapes I have here. So a parabola and a line, right? So think in your head, what are the possibilities here?
2, 1, or 0.
2, 1, or 0, right? With a parabola and a line, I can either have 2, 1, or 0. So how do you want to go about solving this one?
Plug in your
Substitution.
Okay, so negative 4x minus 1 equals negative 2x squared minus 9.
and then move your 4x and 1.
Ooh, wow. Moving the 2x squared.
Okay,
No, 'cause if
so
it gets you a
add 2x
positive-
squared
It gets you a positive 8 on.
and
Yeah,
add
but
9.
Yes, to move it over. It's the same.
2x squared minus 4x plus 8 equals 0.
You still get to see it.
I mean, it works either way.
I'm ignoring your fighting right now, just for the record.
It's not really.
They were trying to decide if we move it to the left or move it to the right. You know it doesn't matter because at this point we could take out a greatest common factor. And either side you would take out the greatest common factor. Here we would have to take out a 2. If we moved it to the other side, we'd just have to take out a negative 2, right? X squared minus 2x plus 4. All right, what two numbers multiply to be 4 and add to be negative 2?
I just wait for you.
Do you have to do the quadratic formula?
Yeah. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals 2 plus or minus the square root of
Negative 2 squared.
negative 12?
Negative 2 squared.
Well, I already did that. It's 4. I didn't write negative 2 squared because I know that that's 4. Sorry. But 4 times 4 is 16, so 4 minus 16 is negative 12, right? What does that tell me right there?
Imaginary.
Imaginary,
They don't touch.
which means
No solution.